right there. Record. We're good. Okay, now share your screen.
Okay, we go share, and you had me doing this at the end of last meeting, and I believe this is what you were about to give me now.
I'm gonna right now. If you're defending, you do not want to read this off as is, because they're gonna jump all over you. You're gonna make it real short, right to the point.
Real short. What really matters from all this, or what they want to hear from this?
The number one thing, the first thing you report, was it a significant regression? Yes or no?
I would say on all of them, yes.
Correct, right. So you're going to start off with the first one. Okay, the hypotheses. First of all, the regression was significant. And then the second of all, you say, which predictors were the significant predictors?
Okay, so according to the other one, we have training is the highest. The regression was 6. And then
here, pull up your PowerPoint. You can read them right off your PowerPoint.
Yes. Okay.
Now they might give you some stuff about putting the entire table into a PowerPoint, but personally I like it. I like to see the data. Some of your teachers might not like to see all that data, but you know, too bad.
Yes.
All right, so the first thing you look at is that top analysis of variance, the ANOVA box. And you don't have to say it. You're just going to say, okay, the regression was significant, right? There's the ANOVA box, there's the sig value. And then you go down to the coefficients box and you say, which of these predictors were significant? And never mention the constant, okay? The constant is not what you think it is. Forget it, don't mention it. No, they don't know what it is either, so.
Which one is it, the constant?
The constant is always the first one listed.
Oh, the constant, okay.
Right, it's always the first one listed.
Yeah,
so
if we
look at efficiency. Efficiency was not significant, training and development was not, but application was.
Application, and there was another one too.
Yeah, and transitioning.
And transitioning.
So for this one, real quick, 30 seconds, you would say, all right, here's the predictor variables, read them off, right? Efficiency, training, application, and transitioning. The DV was, what was the DV?
The DV was the AI factors, which is the constant. No.
No.
Oh, the DV on the other side. Okay.
Do not mention the word constant again. Do not mention it in your dissertation.
Okay.
They will jump into your shit both feet. So.
Okay, we'll forget about that. Then I will put another table.
No. You're fine. This looks good enough to me. It might look good enough to them. They'll tell you if it's not, right?
Yes. I'll make it, because I didn't know how to represent it any better than this, and this is how it should look like from my perspective. And if they need anything, they can look at the.
Okay, so again, let's start again. So with each one of these, you're going to say, okay, you're going to list off the name of the variables, right? The variables, the predictor, call them predictor variables, are efficiency, training and development, applications and transitioning, and the DV is the AI, right? Just leave it at that.
DV is AI, okay?
Right, the DV is the AI. And the AI was a score that you, if anybody asks, right, it's, how did you create the variable AI? You're going to say you created it from several different survey questions about how effective they think AI is, just right to the point.
Okay.
And then you say it was a significant regression. And the only two significant predictors were application and transitioning. Efficiency and training were not significant. And then you list the largest, the strongest of the predictors. And for you, that would have been
training.
Correct. Training. Good.
Yeah, it's 1.6.
Good. Now, part two is the data did not violate any of the assumptions. In fact, you might want to say that once
Yes.
and write this down because they're going to ask you, what are the assumptions?
Okay. So that
So
data.
they ask you, I'm going to tell you what they are. Tell me when you're ready.
I'm ready.
Linearity is number one.
Okay. If we stop this and if we go one more time to this one here, we will see that we put linearity, autocorrelation.
Those are the ones.
Yes.
So if they ask you, did you check the assumptions? And you're going to say yes, and they didn't violate. None of the assumptions were violated, but somebody like Aaron, he might say, well, what were they? And you're going to say linearity, autocorrelation, multicollinearity, multivariate outliers, and or homoscedasticity.
I'll say them. It's not going to be, yeah.
Now, what I'm afraid of is somebody might say, oh, well, what's autocorrelation? And you're going to say, that's a good question, but I was just telling them that you were reading off the SPSS output and none of them were significant. So.
And none of them was significant.
Correct, which is good news, right? So, all right, I'm going to give you the real short definition of all of these. You ready?
Yes.
Linearity, all that means is that there is a non-zero correlation between your IVs and your DV.
Cool.
Okay, autocorrelation, just say this, say it's a lot like multicollinearity, where you have two of the predictor variables are strongly correlated to each other.
Okay.
Multicollinearity, same thing. You got two predictor variables that are stronger. They're more strongly correlated with each other than they are the DV.
Okay.
And change multivariant to multivariate. So get rid of that N and then put a T at the end.
T.
I'm sorry, an E.
Okay.
Good. Perfect. So multivariate outliers means that you have outliers in more than one variable.
Okay.
And homoscedasticity, all you got to say is this, is the residuals are, oh my God, how would you say that without, I don't want you to confuse anybody because they might take that as a challenge. Homoscedasticity is, I got it. The residuals are evenly spaced across the line. Just say that.
Okay.
Because I don't think any three of them know what that means. Okay, good, got it, good.
Yes.
Back to your PowerPoint.
This way?
I'm not seeing your PowerPoint. I'm still seeing your Microsoft document.
Okay. Do I have to stop share this one and go share again? And we go here. Okay. So this.
All right. So, okay, good. You know what to do? Do it on the second one. Pretend I'm your board there. So go to your second hypothesis.
So this is the second, and we will say that there is
wait, first of all, they're going to want to know what is the hypothesis. So just read it.
The hypothesis. Yeah. So since we put two of them, and according to this data here below, there is a significant effect on selecting and hiring.
Stop. What do you mean by effect? So if they ask you that, you're going to say relationship.
Okay.
You got it? If they ask you, what do you mean by effect? You mean relationship.
And does it have to be positive or negative?
No, it doesn't matter.
It doesn't matter. Okay.
All right. So continue.
And taking a look at all these AI predicted variables, we see that they're all significant. Except
Wait. Okay, I'm going to do this one for you too.
Okay.
So you remember, watch this video about 15 times.
Yes.
When you switch to this page, you're going to say, all right, here's hypothesis 2. There is a statistically significant effect on AI and
selecting and hiring.
And selection and hiring, right?
Mm-hmm.
So just say the IVs are the same as the first hypothesis. In fact, the IVs are same for all 4 hypotheses, right?
Mhm.
And if you forgot, they were efficiencies, training and development, application and training. Those are the predictor variables. And the DV in this one, the outcome variable, is selection hiring. Okay, so you start there. You identify what the predictors are, what the DV is. Part 2, it is a significant regression model, right? Because the ANOVA box has a sig value of 0.000. And shit, okay, hold on. Let's finish this. And then you're going to go down to the bottom box, the coefficient table, and you're going to say all of these were significant, right? This efficiency, training, which means they were all significantly related to selection and hiring. And the strongest one was
3A, also training.
Also training. Now, okay, that's all I got to say for each one. And then from the first one, say none of these regressions violated any of the assumptions. Just say that once so you don't have to repeat
Any
yourself.
of the assumptions, okay.
Now, what you didn't put in here is you did not put the effect size, the R squared.
The R squared, okay.
Yeah, you got to mention the R squared. I think that's on your output. Go back to your Microsoft document.
Okay, if I go to this one. Right here. Test hypotheses.
In fact, go to your first hypothesis. There it is right there. Okay, there's an R squared. I don't know if that's the first one.
Yeah, there are many. This is the first. Yeah, here.
There it is. Stop right there. So your first R squared is 0.460. So you got to mention that. And for every one of your hypotheses, you have to mention the R squared. That's what we call the effect size.
The effect size. Okay.
So after you say, yeah, it was a significant regression model, right? And then I would say right after that, say it was a significant effect size, or it was a significant regression model. And then the effect size was 0.460. And that's strong. Just call them all strong. That's a pretty strong effect size. And the definition of an effect size is, if they ask you what's effect size, you got to tell them. Effect size is the percent of the variance in the DB that you can explain with your predictor variables. So remember, the variance is the different answers.
Yes.
So with this model that you have right here, you can explain 46% of the variance in that DB, which is actually quite a bit.
Okay, cool.
All right, so there's the first. Write that down somewhere, because you got to tell them when you're telling.
I'll take this since we're recording this. I'll take it and write it down, everything from the beginning to end.
Good. Okay, back to the PowerPoint, and you do number 3. Remember, right to the point. Read off the hypothesis, and just tell them, the predictor variables are the same as the last 2, but this DV is blank, blank, blank. Was it significant? What was the effect size? What was the R squared? Which predictors were significant, and which one was the strongest?
Okay. Same thing here on the third. We'll say there is no significant.
Wait, I'm not seeing nothing.
No.
Dude. Much better.
Much better.
Okay. From the beginning, please.
From the beginning. So there is a significant effect and or relationship.
Wait. I would just read it off as you have it, and wait till somebody asks you. Somebody will. Somebody say, what do you mean by effect? And you're going to say relationship. There's a relationship between these variables. That's what you're calling an effect.
between the variables of AI, which are efficiency, training, application, and transitioning and appointment.
Correct.
Okay. And according to the multiple regression test, the
Actually, it's according to the ANOVA. That's your first box up there. According
Okay.
to the ANOVA, the regression is significant.
the regression, okay, so we don't say that it's just significant because it's here zeros. Okay, we'll say that the
They might ask, okay, that number, that sig number has to be less than 0.05.
yes, zero. Here, what is it here?
Right, the sig
Zero,
value.
yes, 0.05.
Right, it has to be less than that number. Now it's listed as sig. That means significance in from the SPSS, but we don't call it sig value. We call it a p value, the probability value.
The p value, okay.
Yeah.
So p value. Okay. We got that, and then we'll say that also according to the multivariate regression coefficient table here, or that is a test, right? It's not the table, the test.
Which one are you talking about?
The multivariate regression coefficient.
No, that's just called the coefficients box.
Okay, so it's not the test.
No, that is not the test. The first one, that first one is the test.
The ANOVA.
Right, the ANOVA is the official test. If that's significant, the regression is significant.
Okay.
Right, you're going to say, you know, according to the ANOVA, the regression was significant.
Nice. And for the other one, we'll say that.
Okay, and then the R squared is blah blah blah, right? With a strong with a strong effect size of blah blah blah. R squared equals whatever the R squared number is.
Okay, and then I will jump to this last one here.
Right, you write down to the coefficients table.
Coefficient table, and we'll say that all of these variables are strongly related.
Wait, no. Are they significant predictors or not? That's when you look at the sig column on the right.
Sig, yes, all of them, but transitioning.
Exactly. So all of the predictors are significant except for transitioning. So which one is the strongest predictor?
And the strongest is also training.
Good.
Mm-hmm.
Good job.
And that is from the beta column. And yeah.
All right, do the next one for me.
It's going to take me a little while because I have to write everything down. Same thing. There is.
Good thing we're recording this, huh?
Yeah, exactly. I'm going to sleep on it. Yes. Yeah, like just listening to it all night long. And yeah, same thing here. We'll start with the first sentence here. That is a significant effect of AI on competitiveness. And according to the ANOVA, there is a significant correlation from the results here.
Significant regression model, or just significant regression.
Okay. And we'll bring the R square and we'll see what are those values. And we'll jump to this here.
Right.
The last thing, which is the coefficient table.
Right. Good. Down to the coefficients table.
And we'll say that all of these are significantly.
You could just say all of these are significant predictors.
Significant predictors. Yeah, all of them.
Except for
nothing. Oh, yeah, the transitioning.
Yeah, hey, don't make that mistake. I guarantee you, they will attack you. Saba will attack you.
Yes.
If you get these wrong, because you just say, this is your shit. How come you don't know it?
Yes. Okay. And the strongest also training here.
Good.
Yeah.
Now, okay, so now let me do this one, and I'll try to do it as succinct as possible, because very important. this should be quick. Your entire presentation shouldn't take more than like 30 or 40 minutes.
Yes,
They don't want to sit there and listen to you go on and on and on. They've read your stuff, supposedly, right? They've already read it, they've known about it. So they just want to make sure that you can present it, like if you had to go somewhere to some big company and present this, that you could present it quickly, to the point, show the highlights, the results, and then you're done. Bam. Okay, so like this one, I would say, all right, here's hypothesis 4 is there's a statistically significant effect on AI. And these are worded wrongly, dang it. There is a statistically significant effect of AI on competitiveness. Yeah, get rid of
yes.
And they should all be like that.
Okay, perfect.
All right, starting again. Okay,
Yes.
hypothesis 4, there's a statistically significant effect of AI on competitiveness. And as you recall, the predictor variables of AI are the ones down here on the bottom, same as always: efficiency, training, application, and transitioning. And the ANOVA table indicates that it is a significant regression. And if you want, you could say the the p value says 0, 0, 0, which is fine. And the R squared is
whatever that is.
Whatever it is, right? That's a strong effect size. And then dropping down to the coefficients table down here, according to the table, all of the variables were significant predictors of the DV except for transitioning. Period. That's it, right? So that takes under a minute.
Perfect. Yes.
Right to the point. And then after, don't jump slide to slide. Just say, any questions? After the first one. After the first one, say any questions.
Yeah, what I'm trying to add here, I'm just gonna relate what that means, that there is a correlation between these. Because I don't want to go spend a lot of time on that conclusion. So with every hypothesis, I'll try to relate that to actually what happens on the.
Good, right. Okay, now remember, a correlation is the strength of the relationship between two variables.
Yes.
Say that again. A correlation is the strength of the relationship between two variables. A regression uses correlations to determine if the overall regression model is significant. So I'll say that again. Regression uses correlations. They're very strongly related, but they're not the exact same.
Okay.
So remember that.
Yes. Yeah, definitely. I will write those down, and I have to just have them by heart memorized.
Good. Now, remember, don't talk too long.
Yep. Straightforward,
to the point. Ask a lot of questions. You might want to start off with a joke or something, right? Set the tone.
Yes.
Right. Try to think of something, be friendly, and just say, you know what? I'll be as brief as I can. And if you have any questions, don't hesitate to stop and do your thing. Blah, 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 blah.
Yes.
And so you got the interpretations, and then the rest you got to talk about, okay, so you found this out. What are you going to do about it? Right. So
yes, how we can interpret this to the actual workforce, to the company.
Good. And remember again, less is more. These guys have already read your dissertation more than once. So you're just going through the highlights.
Perfect. Yes. Yeah, no, this will set it very clear, like really straightforward. This way I can follow through on all of them, because I was not sure what I'm reading here and how I'm gonna interpret this.
Now, okay, so after you do these big four, you might want to you say, okay, so out of all four hypotheses were supported by the data, right? And then go into the next, or segue into the next thing, saying, okay, now that we found out this information, let's see if we can apply it here or do it there, or whatever you're going to write about. So
yes,
but I think you're going to be fine.
Yes, no, with this is clear. This is pretty much something that I can follow through.
Okay,
Yeah,
so if they ask you a question where you don't know the answer,
Mhm.
you're going to say, you know, that's a great question. I'll get back to you on that.
Right on.
Right. And you pretend to write it down.
Of course, yes.
Because normally they will throw something at you that you cannot answer,
That I
right? Like you're
cannot
not sure.
exactly that I don't know, or it's
Right. And you always compliment them on, oh my God, you're the smartest thing since, you know.
how did you come up with that?
Right. Yeah.
Mhm.
You know, and I'll get back to you on that. So usually what happens is they're going to pass you, but they're going to give you a couple of minor details, like, you know, change this, change that, change that. And then you're done. So
Yeah, perfect. I really appreciate that.
no problem.
You've done great.
You did great. So I'm just a numbers guy now.
Man.
And don't be nervous. Don't be nervous.
No, definitely. Yeah, right now I've been going through all of this, these tables, and I kind of messed myself up, like trying to figure, oh no, this is right. Oh no, 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 that is wrong. What do you think? And I look at it now, it makes sense. A few seconds later, it doesn't make sense. Yeah.
Yeah, you're going to be fine. Watch this video. You're going to be fine. Just, you know, right to the point. 1, 2, 3, 4 things to say about each slide. You're done.
Okay.
Now, you might want to start off with a joke, right? When you start up on Zoom, you can say something like, you know what? I went out and bought coffee and orange juice and some bagels, but you know.
Yes, but now it's virtual, so you're gonna just pretend that you smell it.
You're right. Right. See, that puts everybody in a good mood right off the bat, right? So you got a little sense of humor. That's what they're looking for. So
yeah.
And then just whip through it.
No, that's easy. That's
all right.
That's nice.
I'm gonna quit recording and then send you the link.